Fluid pressure. When a vertical plate is submerged in water, a force is exerted on the plate due to the pressure of the water. This force is often called hydrostatic force. So this hydrostatic force equals to rho, G, and D, where rho is the density of the fluid, G the gravitational acceleration, and if that one is water, density is equal to 1000 kg per cubic meters and G 9.81 meter per second squared. And we have the theorem. The force on a submerged plane area equals the product of the specific weight of the fluid, the area, and the depth of the centroid of the area below the surface. Example 1. A true with a vertical end an isosceles triangle of width 12 meters and depth 6 meters, filled with a lemon juice with a density of 60 kg per cubic meter. Find the force exerted on one end of the true. Letter A, using integration. Letter B, using the theorem formula. So for the letter A, so solution by integration. So you have that one, equation the line. The line is x plus y equals to 6. So your W equals to 60 kilograms per cubic meters. So your x equals to 6 minus y. So your force equals to A times W times y. Or dF equals to x dy W times y equals to 60 y x dy. So your F is equals to 60 integral of minus 6 to 6 y x dy, or equals to, or 1/2 F, or 1/2 F force equals to 60 integral from 0 to 6 y x dy equals to 60 integral 0 to 6 y times 6 minus y dy, or equivalent to 60 times 6y squared all over 2 minus y cubed all over 3, 0 to 6. So we'll continue, equals to 60 times 3y squared minus y cubed all over 3, 0 to 6, equals to 60 times 3 times 6 squared minus 1/3 6 cubed minus 0 equals to 60 times 3 times 36 minus 1/3 36 times 6. So equals to 60 times 36, or equivalent to 60 times 36 kilograms. So 2F is equals to 36 times 2. So 2F is equivalent to 120 times 36, or equivalent to 4,320 kilograms. For letter B, using theorem, using formula, if equals to W A times X equals to 60 times 1/2 times 12 times 6 times 1/3 times 6, equivalent to 60 times 36 times 2 equals to 4,320 kilograms. Note that the centroid of triangle is 2/3 of its base. Find the force on one side of the surface of a rectangle 20 meters wide, 16 meters depth, submerged vertically in a fluid with density of 50 kilograms per cubic meter. Solve by integration. B, by theorem formula. So solution. By integration. So you have this one. dF equals to W times X dy times Y equals to 50 times Y times X dy. So F is equals to 50 integral of Y X dy, where X equals to 20 a line. So if equals to 50 integral of Y dy times 20 equals to 50 times 20 integral of Y dy equals to 1000 times Y squared all over 2, 0 to 16 equals to 1000 times 16 squared. Sixteen squared all over 2. So minus 0. So equivalent to 500 times 16 squared equals to 500 times 16 times 16 equals to 128,000 kilograms. So for the next solution, using the formula for letter B, using the formula F is equals to WAX equals to 50 times 20 times 16 times 8 equals to 128,000 kilograms. Force on one side of the triangle of B 6 meters, altitude 3 meters, with a vertex and base lying 2 and 5 meters below the surface of water, solved by integration. Then by theorem formula. So by integration, df equals to w times x dy 5 minus y, or equivalent to 1,000 kilogram per cubic meters times x dy 5 minus y, or F is equals to 1,000 integral of 3 minus y 5 minus y dy. So equivalent to 1,000 integral of 15 minus 3y minus 5y plus y squared dy equals to 1,000 integral of 0 to 3. 15 minus 8y plus y squared times dy equals to 1,000 15y minus 4y squared plus y cubed all over 3. Limit from 0 to 3 equals to 1,000 times 15 times 3 minus 4 3 squared plus 1/3 3 cubed, or equivalent to 180,000 kilograms. Or 1/2 F. So total force. So total force equals to 1800 times 2 equals to 36,000 kilograms. For the letter B, formula, force F is equals to WE bar X equals to 1,000 kilogram per cubic meters times 1/2 6 times 3 times 2 plus 2 all over 3 equals to 1,000 kilograms per cubic meters times 9 meters squared 2 plus 2 2 plus 2 so this one is my this one 1/3, so times 3 so 2 plus 2 meters, so equivalent to 36,000 kilograms.